Hi there, this is our second chance at looking at exercise 5C.1. I've got a second chance because we got halfway through it and we was able to do by the end of it, use the calculator to effectively find our line of best fit, our least squares regression line as it's called. But we never got a chance really to look at the formulae. So if I'm going to go back to it again, and do that part of the PowerPoint now. So the formula I showed you was that the gradient of the line called B is simply Sxy divided by Sxx. And we've seen those before. They're the formulas which we're going to use in a bit. And I also mentioned the fact that I do this little trick where I use y minus y bar equals bx minus x bar. Now, you don't see this in the formula book and you don't see it in any textbooks, but effectively, I think it's the easiest way to do it because you already use this formula effectively in A-level maths in the pure part. So you use our y minus y1 equals m x minus x1, and that's because you know it goes through the point x1 comma y1. Now what we do, we know it goes through the point, that's a comma on this, we know it goes through the point x bar comma y bar, and the linear regression line will always go through the point x bar comma y bar, so we can use that. And of course I mentioned last time that this m is really another way of writing the gradient. So on that basis, let's do this. Now we've got some boy who's counting the number of presents he gets for Christmas and how many he handed out as well. Now the ones he handed out he's called X, the ones he receives are called Y. And these are the summary statistics. And it says find the equation of the y on x regression line. That's the way it's often written, the y on x regression line. And that's because there is a second regression line called the x on y regression line that in past iterations of A-level further maths and A-level maths I've had to teach my students. But on OCR at least, and you should check whatever board you're doing, but OCR you only have to find one regression line. It's the y on x regression line. So that's what you're going to see here now. So on that basis, I'm just going to find these things. I'm going to find Sxy. Now, if you remember, the formula basically is sigma xy minus sigma x sigma y over n. So that's 792 minus 29 times that 42 divided by 10. So if I just do that on my calculator now, 792 minus 29 times 42 divided by 10. And I get 670.2. So that's the first bit done. I now calculate Sxx, which again is very similar. I do sigma x squared, so 397. And now I just do the sigma x, 29 squared divided by 10. So 670.2. I don't know where I said that. 397 minus 29 squared divided by 10. Got there eventually. And I get 312.9. Now to get my b then, it's very simple. I do, and again, if you just look at the formula from before, it's just the Sxy divided by the Sxx. So it's the 670.2 divided by 312.9. And that sounds about 2-ish. 670.2 divided by 312.9, and I get 2.14. So I get a value for my b. Now that's actually, I think, the easy one. So I'm just going to write up here b equals 2.14, allowing for a bit of rounding errors, which I might get in a bit. And I'm going to rub out all this stuff at the bottom because I'm going to use this space now to work out my actual equation. And of course I'm missing my a at the moment. So if I go back to my pen, now I suggested we needed to use this y minus y bar equals b x minus x bar. And of course I kind of did know my values of my y bar and my x bar. My y bar and my x bar, it's just 29 over 10 and 42 over 10. So on that basis, I can just write down this as y minus 4.2, that's my 42 over 10, equals 2.14 x minus, let's just remind myself, what was it? There was it. Oh, 2.9. 2.9. And I can multiply that out. Y minus 4.2 equals 2.14x. And the only multiplication I've got to do is cross out 2.14. Now I've left my whole number on my screen, so I might get a slightly different answer to you if you've rounded. But it's roughly 6.2. It's actually 6.21. 3 figures. If I move the 4.2 over, I get my final equation. Now that's going to be a plus 4.2, and it was minus 6.2, so I'm going to do 4.2 minus 6.21, and that is 2.01. Well, technically minus 2.01, and that's my A plus my B x. So I've written it that way around. It could easily have been written down more feasibly as 2.14x at the front. So what did I get as my answer over there? 2.14, and that's the right equation underneath all that. That's what we got. So that's quite a nice example. And here's another example, which I'm going to do as well. I'm going to take my time doing it the same as before. Now, of course, this question has some kind of story behind it as well. This is about the test scores and the age of different children, and the age is X, it seems. But the bottom line is, I suppose, they give me this summary data. So I can use this to find SXY first of all. SXY is equal to sigma XY 4251 minus, and I have to do sigma X times sigma Y, 58 times 507 divided by 7. And if I just type it into my calculator, okay, I got 50.143. I'll give it to 3 decimal places. And then I want SXX. And again, I do a similar thing. I do the 488, sigma x squared, if you like, minus the 58 squared divided by 7. And this time I get 7.429. Again, giving it to 3dp. Now, B, of course, is these two things divided by each other. So 50.143 divided by the 7.429 is equal, according to me, to 6. Well, I got 6.75, a couple of zeros actually. So 6.75, depending on how round you rounded up, of course. Now, the next thing I need to do is use my y minus y bar equals b x minus x bar formula. So it implies I need those two things. So let's find them now. So x bar is 58 divided by 7. So let's just do it now. 58 divided by 7 is 8.29. 286, I suppose, if I was doing 3dp. And y bar is, what is y bar? It's 507 divided by 7, which is 72 and a bit. Where's my pen? It's there. So 72.429. Now I can use this then. I can therefore say that y minus that 72.429, make sure I've written that down properly, equals my b, which I found as 6.75, pretty much dead on actually. My x minus x bar, 8.286. And the only thing I'll do, I suppose, really is multiply this by this. So 6.75 times by 8.286, 55 and a bit. So 6.75x minus 55.9305. And of course, now I move the 72 over, I get an equation that ends y equals, well, I'll put that number first, so it becomes 72.429 minus the 55.9305, I think I said right. By the way, it's 16 and a bit, 16.5. I'm going to write my final answer to 3 significant figures, having been done it as accurately as I could throughout that, plus 6.75x. So that's what I reckon it is. What do I get here, my answer? Yeah, that looks underneath all that. It looks as if I got it right. So look, note a few things. I did say that this is an important idea, and I have seen exam questions that say no, to explain which point no, the line will definitely pass through. So the regression line always passes through the point x bar, comma y bar. They don't tell you the x bar and the y bar point. You'd have to work it out, but you know it will happen. You also know it says you can always find a regression line. Even though you can always find the regression line, rather, it will have no meaning if these points are like just not very close to your line that you end up with. So I do see people doing this where they get a set of numbers and they kind of do this and they ignore the fact that it's curved, and then they find the line of regression through it and it does that. And you kind of think, well, yeah, it kind of, you can see they kind of do, but really the regression line you wanted was a curved one, and that's not on our syllabus. So if you got this, you would say it's curved, therefore I can't do it. Whereas perhaps at university, you'd find what that was. So just be aware of that. And we're often asked to comment on the reliability of predictions, and we saw this in one of the questions on one of the two videos. Bear in mind then, you should be looking at whether or not you need to extrapolate. Remember, go beyond the original points, the x values. If you do, then it possibly won't be a very good estimate. And you should also consider how good the correlation is. I've seen this come up loads on exam questions. And again, if you were doing this, it might look something like this, whereby you have a scatter graph and it really is all over the place. You know, it's, yeah, you can find the line of best fit through it, but it's not very good. Now, how can you show that it's not very good? Well, if you find Pearson's product moment correlation coefficient, you might find that R is only 0.21 or something like this. Really rubbish. And don't be surprised then if you haven't got very good correlation. Don't be surprised you haven't got very good line of best fit. And that's really what it is saying there. So on that note, just be aware that we're going to have a look at exercise 5C, and I'm sure a lot more things will come out in the wash. So thank you very much for watching.